Now we start with question 3. They say ABC is a triangle with vertices A, which is 1 and 3, B, which is negative 2 and 0, and C, which is P and negative 4, where P is greater than 0. Right, now they say to us the length of AC is root of 50 units. So AC is this line over here, right? And they are telling us that is square root of 50 units. Right, so firstly, they want us to determine the gradient of AB, right? So we can do that quite quickly. So the gradient of AB, y2 minus y1, I'm going to say ya minus yb over xa minus xb. Right, so our y value for A rather is 3. So I'm going to say 3 minus 0. So that's 3 minus 0 divided by xa is 1 minus a negative 2. Okay, so 1 minus a negative 2 gives us 3. So that will be 3 divided by 3, which gives us 1. So the gradient of AB is equal to 1. Right, now they say show by calculation that P is equal to 2. Right, so we've got the length of AC there. Right, so we can use that length, and we know that if we take the distance formula, AC would be equal to the square root of XA minus XC squared plus YA minus YC squared. So we know that this is equal to square root of 50. And so the square root there should be the value of A, XA, that's 1. So that's 1 minus P all squared plus, right? So this is going to be 3 minus A negative 4, right? So that's 3 minus negative 4, right? So I'm just going to put that in square brackets. That's squared. All right, now obviously what we're going to do is take the square root on both sides to remove the roots. So that's 50 is equal to, so that root cancels, the square cancels out the square root. So this would give us 1 minus P squared plus, okay, that's 3 minus a negative 4, which gives us 7. 7 squared is 49. All right, so now that means that 1 minus P squared, okay, 1 minus P all squared rather, is equal to, now if I say 50 minus the 49, that gives me 1. And so 1 minus P, right, will be equal to plus or minus 1. And so that means if I'm looking for P, there are two values of P. So it's either P is equal to 2. Okay, so if I take 1 minus, or rather, that is 1 minus the 1 or plus the 1, that will give me 2. Or I will have, or P is equal to 0. Right, so definitely we are going to take this one because they did say to us that P must be greater than 0. So therefore P is equal to 2, which means this is not applicable. Right, now let's go to the next one. They say determine the equation of the perpendicular bisector of AB. Now, what is a perpendicular bisector? Right, so it's a line that would cut AB into two equal parts. So that means we need to find the midpoint of AB, right? So we're going to say, all right, let's call it M, right? So M would be the midpoint of AB. So that's negative 2 plus 1 divided by 2. And also for the Y value, we'd have 0 plus 3 over 2. So which means that midpoint is going to be, so that's negative 1 over 2 and 3 over 2. Now, if it is a perpendicular bisector, we just found out that the gradient of AB is 1. So meaning that the gradient of the perpendicular bisector must be equal to -1, right? So because they must be perpendicular to each other. So the gradient of the perpendicular bisector, okay, is equal to -1. Remember that the product of their gradient must give us -1, right? So in this case, so let's say, so the equation would be y is equal to the gradient is minus x plus c. Now let's put in our points, the coordinates of c there. So when y is 3/2, we know that x will be -1/2 plus c. So if we take that, so this is going to give us, okay, so in fact, that's going to be +1/2. So 3/2 minus 1/2, that will simply give us 1. So the perpendicular bisector there would be y. The equation is y is equal to -x plus 1. Right, I hope that we get that. Right, so they say to us, write down the coordinates of D such that ABCD is a rectangle. Right, now remember, if this is a rectangle, we haven't calculated anything about the sides, but we do know that it means this would be a 90-degree angle, right? So I already should know that the gradient of CD should be equal to the gradient of AB, okay? And so that tells us that gradient should be 1, all right? We just found in this case, or rather, we know that the gradient of AD should also be -1. All right, I'm just going to look for some space there. Okay, yeah, let's just try to get some space. Right, so they said write it down, which concerns me just a bit, because it makes it seem like you're just going to get that value. I don't know if you can, just find that value. Please let me know how. Okay, but in my case, what I'm going to do is I already know, okay, let's just remove that. So I already know the gradient there, and I've got a point. Remember, we know that P is 2, right? So the equation of CD is y is equal to, this is x plus c, and so that would be, if y is -4, right, x is 2 plus c, so c is equal to -6. Right, so the equation of CD, okay, is y is equal to x plus, or rather, y is equals to x minus 6, right? So that's the equation of CD. The equation of AD, right? So we know that the gradient should be -1. And we know we've got a point that is at A. So that equation, so this is for CD. Okay, this is the equation for, okay, plus C. So we've got when y is 3, x is 1 plus c. So I will get c is equal to 4. So the equation there for AD is y is equal to -x plus 4. So what I'll do is I'll equate these two equations. Okay, so I know that x minus 6 is equal to -x plus 4, right? So if I take the x to the other side, I've got 2x. If I take the 6 to the other side, I've got 10. So divide by 2 on either side. So x is equal to 5. And of course, to get the y value, In this case, I can substitute on any of the two equations. Okay, I'm going to substitute to the easier equation. Well, actually, both of them are not that bad. So if I substitute x is equals to 5, I get -1. Okay, right, so the equation of D, or rather the coordinates of D, are 5 and y is -1. Okay, right, so they say to us, determine the equation of the circle passing through ABC. Right, so if we had a circle that would pass through these points. If you don't mind, ladies and gents, I'm just going to remove all of this. Okay, so I am going to have in the circle, right, so if I had a circle there, okay, I know my circle is not perfect. Right, so remember, by virtue of this being a 90 degrees, so this would mean that AD, or rather AC, would be our diameter. And why is that? Because remember, in this case, the angle that is subtended by a diameter is equal to 90 degrees, right? So as a result, this means that I need to find the midpoint of AC rather. So I need to find the midpoint of AC. So the midpoint of AC would be equal to, so that would be the center of the circle, right? So that would be 1 plus 2 for the x value, 1 plus 2 over 2. And for the y value, I would have, that's 3 minus 4 divided by 2. So my midpoint in this case would be 3 over 2, right? And -1 over 2. All right, now I need to now find out what is actually we do know the distance. The length of AC was actually square root of 50, right? So already I'm halfway there, because it means the equation of my circle would be x minus 3 over 2 squared plus y plus 1 over 2. Remember that it changes sign once it's in the bracket. Now let's find out what is the length of AC. It's square root 50, but I know that it means that my diameter, my radius, is half the diameter. So half of root 50, I'd say square root 50 divided by 2. But remember, we always say r squared in this case. So that means that if I say r squared, that would be 50 over 4. So that would be my, so if I say 50 divided by 4, that's the same as 25 over 2. So that is r squared. Okay, so that's the equation of the circle that's passing there. We said that's x minus 3 over 2 squared plus y minus, or plus rather, 1 over 2 squared, which is equal to 25 over 2. Right, now they say determine the size of theta rounded off to the nearest whole number. Okay, so we want to find out what the size of that angle is. So what I'm going to do, ladies and gents, this angle over here, angle theta, right? Actually, there are several ways in which I can do it. I can either, all right, I want you to see this. So remember that if it's a rectangle, it means that these would be alternating angles. Okay, so which means that theta is equal to angle A1. I can find A1 if I take triangle ABE, and that becomes the exterior angle of that triangle, which is equal to the sum of the opposite interior angles, right? So that means that A1 plus B1 is equal to E1 if I use the exterior angles of a triangle. Right, if you don't mind, I'm just going to remove all of the stuff so that we can calculate that. So we're going to look for the gradient of AC, right? So the gradient of AC is actually 3 minus a negative 4 divided by 1 minus 2, and so that will give us 7 over negative 1, so this would be negative 7. Okay, now I'm going to look for the angle, right, E1. So remember that the tan, okay, of E1 is equal to negative 7. So therefore E1 would be equal to the arctan, okay, of negative 7. Right, so I am going to use this and say shift the tangent of negative 7. Okay, I get a value of negative 81 plus, okay, let's say plus 180, because that gives us this angle over here. Okay, so I'm going to say plus 180. Okay, that gives me 98.13. 13. Right, so that's the angle E1. And so now I can also look for the angle B1. And remember, I already know that AB has a gradient of 1. So that means that the tangent of B1 would be equal to the gradient of AB. So B1 would be the arctan, or the inverse tan of gradient there is 1, and so that means that is 45. Now to find the angle A1, or rather let's say E1, is equal to B1 plus A1. We say this is the exterior angle of a triangle. So this is in that triangle ABE, right? So we're saying that the sum of the angles, or rather the exterior angle of a triangle, is equal to the sum of the opposite interior angles. Right, so now, which means that A1 would simply be 98.13 minus 45. And since they said to us to the nearest, they say we must round off to the nearest whole number. Okay, so that would give us, okay, so that's 98 minus 45. Okay, that gives us 53. So the angle there to the nearest whole number is simply 53 degrees. Right, I hope that you got it. Okay, so using exterior angles on a triangle. Right, now to the next question. They say to us 3 straight lines, that is AB, RS, and x is equal to 3, intersect, or rather intersect each other. The equation AB is this, okay, where B is not equal to 0. The equation of RS is that guy there. Calculate the value of B. All right, so we need to find out where they intersect, okay? So we at least have one equation where they intersect, that intersects with the others. So we know they intersected x is equal to 3 because that's part of the point, right? So I can find out the corresponding y value. That's minus 2 over 3 times that negative 3 plus 2. Okay, so negative times a negative becomes a positive. The 3 cancels with the 3 there, so 2 plus 2, that would be 4. So the graphs intersect where x is negative 3 and y is equal to 4. So now I can substitute that point there. I'm going to say 3x, so I'm going to substitute it to that equation. 3 times negative 3, right, plus b times my y would be 4 at that point, right, would be equal to negative 2. So to find the value of b, that's 4b, right? So that's negative 6. If I take negative 6 to the other side, it becomes positive. So it's 6 minus 2, which will give us 4. And so b would simply be equal to 1. So that point there would actually be, rather b should be equal to 1. And ladies and gents, that is how the cookie crumbles when it comes to this question. I hope that you are able to understand and enjoy it, right? And let's go to the next question.